Hey guys, this is the second section of 9-2. A lot of this has been review, so this should be a pretty quick one. 9-2 is on the perimeter of and area of triangles and trapezoids, which we've used the triangles formula a little bit, and trapezoids one we kind of touched on a little bit. We're going to basically plow right through them right now. But before we do anything, we know what a triangle is. A triangle is a three-sided polygon. Any three-sided polygon. 3 line segments, that makes a triangle. Trapezoid, I wanted to give you that definition. Now this is a trapezoid. It's a quadrilateral with at least one pair of parallel sides. And I have a different definition in the book. The book says exactly, that's not correct. Quadrilateral with at least one pair of parallel sides. And I'll talk more about that in class. Okay, so get that written down. Okay, here we go. Example number 1. We know how to find a parallel of something. We just count and add the sides together. So we're gonna do parallel. We're gonna use perimeter. We're gonna use the perimeter, not find it. So let's read our question. Let's see. If the trapezoid has a perimeter of 50 centimeters, then what does x equal? So we know the perimeter is equal to 25 centimeters. So that's very important to write down. So we're gonna write that down first. So we're gonna write down P equals 50 centimeters. And I'm going to keep that just right on over there. Okay, so if the trapezoid has a perimeter of 50 centimeters, what does x equal? Well, let's talk about how would we find a perimeter usually. And this is where the equations for writing down an equation for perimeter is very important. So let's see. Normally we would find, well, perimeter is equal to, let's add all the sides together. We got 13, got 14, and we got 19. We know what those sides are equal. We know those sides. So let's go and just write those down. 13 plus 4 plus 19. But those are only 3 sides. Our fourth side has got to be x. So we're putting x right there. So we're solving for that guy. Well, let's combine the like terms. I'm gonna make my balance line 17 plus 19 plus x, and that's 38 plus x. So we're basically pretending for a moment that we're trying to find the perimeter, but we don't know what x is. But we do know what the perimeter is. So we're going to do something called substituting, and you're going to do a lot of substituting next year. So we're going to practice a little bit right now. We're going to replace this P with that P. So I'm just going to say 50 equals 38 plus x. Okay? And now we're going to solve it. I'm going to add negative 38 to both sides. These two are going to equal 0. That's gone. So x equals 50 minus 38. Should be 12 centimeters. And we're done. That's it. So, seemed like this is going to be a word problem. It's not too bad. If you're looking, so this is us, we're not finding the perimeter. We're actually using it to find an unknown. And that's really, really valuable. So, that's our first example. Go ahead and take a minute to ponder the universe. Here we go. Example number 2. So example number 2, I'm asking you to find the triangle's area. And let's definitely write down the equation first, which we worked on a little bit in class today. We know area is equal to 1/2 times the base times the height. And the first thing you're going to notice is what? Well, if this is the base, that's the base, then this would be the height, because it's a right angle right here. We don't know what this side is. We're missing that guy. Right triangle, looking for a missing side. We know what 2 sides are. I'm going to write that down in my tool bag. right triangle, missing side. That sounds like job 4, a squared plus b squared equals c squared. Pythagorean theorem. So our first step isn't plugging into an equation. We can't do that yet. We have to find h. So I'm going to call this h right here. Step 1, we got to find the triangle's height. Can't do anything without it. So we'll start with a squared plus b squared equals c squared. Okay? First thing I'm going to talk about, as always, what is that called? It is, because when it's opposite this, that's a special thing. That's the hypotenuse. Not A, not B, it is always C. So let's plug that in. 25 squared equals, now 20, doesn't matter. You choose A or B. I'm just going to go with A. And what's B equal? B equals just, I'm just going to call that H. We're going to solve for, because we're solving for H first. So let's call it that. Okay. 2 times 2 is 4. Add 2 zeros, right? Equals 25 times 25 is 625. Make sure I got that right. 5, carry the 2. 10 plus 2 is 2. Carry a 1. Space holder. 2 times 5 is 10. I don't know why I put that line right there, but whatever. It's 10, so now we got a 1 right here. We got 2 times 2 is 4, plus 1 is 5. 5, 2, 6. Yep, okay, so we're good. Positive 40 on one side. We're going to add negative 40. We're going to add the opposite. Or negative 400. 0. A squared equals 225. Almost said 250. Opposite of a square is the square root. If you can't remember in your notes, this is pretty important. 225 squared is 15. H equals 15. Okay. So that's the height. That's step 1. So I'm going to come up back to my picture and say that equals 15. Not done yet. Now we got to use our equation. A equals 1/2 times the base times the height. Now we know what the height is. Step 2. Area equation. Okay? A equals 1/2 times the base times the height. Always start with the equation, no matter what. In any subject, science, math, history. You don't use equations in history, I take that back. 1/2 times the base, well that is 20 times the height. We just found that, 15. I'm going to do a little fancy maneuver. Half of 20 is 10. And 10 times 15, 150. I never put any units on it. Let's call it feet squared. Let's go and go back up here. I'm just going to call it all of these feet. That's a foot, that's a foot, that's a foot, that's a foot. I didn't put any units. I like to have units. 150 feet squared. That's the area. We're done. That's it. So you do need to go back. This Pythagorean theorem, we did it a little bit in chapter 8. It's coming back in chapter 9. Very, very important. Very key instrument. So it's definitely on your test coming up on chapter 9. Okay, that's example 2. Any questions? Please take some time. I know that one's pretty fast. In case you need to write anything. Okay, ready? Here we go. Example number 3. Example number 3. That's a trapezoid, so we're going to find the area. So if you remember from our activity that we did today in class, we actually played with the triangles and we played with trapezoids to figure out what exactly is the area, or what's the equation. Well, here we go. Area is equal to 1/2 times the height times the sum of the bases, base 1 plus base 2. Because if you remember, we took the two trapezoids, we photocopied them, rotated one and glued them together and made a parallelogram. But we got divided by 2 because I had 2 of them on here. So, here we go. Find the area. Find the area, nothing's missing, right? Let's just do it. Area equals 1/2 times the base. Oh, times the height. See, look, I'm already messing up. Base 1 plus base 2. 1/2 times. Okay. Well, here we go. What's the height? Height's 3. Base 1. Don't know why I wrote a B right there. I'm going to put a parenthesis inside a parenthesis. Base 1 is equal to 4.5 plus base 2, which is 7.5. Okay, keep in mind equals lined up. Now we're done with the picture. Got our equation ready to rock. 1/2 times 3 times, why are we doing parentheses first? Oh, order of operations, grouping symbol. Well, we gotta line up the decimals when we add these, right? 10 carry to 1, 2, 12. So this is gonna be 12. Don't need a decimal. That's 12. I'm not gonna do this first because that's gonna give me a decimal. I know it is. However, 3 times 12, I'm gonna use associative property to multiply in my order. I get to choose. If all I'm doing is multiplying, do it in any order. Any order that you feel like. 36 and half of 36, 18. And we got our feet squared. That is our area. We're done. So at the very end, always divide by 2 on trapezoids and triangles, because we basically found their area formula exactly the same. We had to double them, rotate, equal, glue them together, made a parallelogram that was too big. It was double. That's why we divide by 2. So we talked about that in class today. But that's actually using the equation. Expect also in a few days I might miss something and give you the area, just like on our second example. Our first example, I might do something like that, but not then with area. So expect that sometime tomorrow. We're going to do something with that tomorrow. Okay? So, get a good night's rest. Have a great night. Short lesson tonight. So, good luck.